It sounds like the first order of business is to sort of figure out these new sort of protocols that can drive new business use cases or enhance, business payments. How do you get to the app layer from there? Because you have the technical capability 100% to build out these different protocols that are new and different, but how are you thinking about the next level above that? How do you get there?
Absolutely. Like that is the number one concern in my head. I think generally, so since we're an L1 blockchain, like we are an alt L1, and alt L1s face an incredible amount of adverse selection. The developers that come to build an alt L1, a large portion of them are saying, hey, I pretty much just want to index on growth, and then I'm going to come there and deploy a DEX, and then deploy old protocols that exist in other chains, and then come on, and then just do it with this new chain, and hopefully you can just beta it. And I think it's a pretty smart thing to do, honestly. Like when I first got started in crypto, I was like, this is actually a great play. I think from the create net value perspective, if you're looking at the industry level, that probably doesn't help as much. And because of that, the way that we're going to do this, like we're going for mainnet around Q4. And because we're going to mainnet for Q4, Q3, we're going to host a builder residency where we go very top heavy, host 5 teams in our office in New York, where for every single team we're putting, like I'm spending a lot of time with each one, helping them come up with this differentiated value proposition, figure out distribution over here. A lot of what we believe in a team are newer tactics for getting apps off the ground. Like we're a younger team, and a more aggressive team where we're going for TikTok marketing and word of mouth, crazy displays out in the streets. All of this is in the pipeline. It should be fun.
Amazing. I think, it's funny, you see a lot of L2s and they're not necessarily differentiated. And it's like, okay, well, you're starting an L2. What are the first things you're going to need? You're going to need an AMM. You're going to need a loan app. You're going to need, I don't know, a perp protocol. And so there's all these like primitives that are, people are just copy pasting. And I think what's interesting about Seismic is you're a little bit more targeted in that the primitives don't really matter. It's the applications.
Yeah.
It's the end user.
Yep.
And the value you can bring to the largest market of end users that are out there.
I couldn't have put it in a better way. That's exactly our take on it, where if you focus on the edges, the assets, all of the ways that these assets can move within your chain are going to come together. Like at the end of the day, a layer 1 blockchain is an asset ledger, and it's evaluated by the quality of the assets that are on it, not how quickly or how well these assets can move.
I feel like you've been asking the number one most obvious question that no one's been asking for the last 10 years.
Thank you. I appreciate it. I mean, a lot of these have taken directly from advisors that we've been fortunate to have as a company. Like they just say, hey, your approach is completely wrong. We've seen this for the last 10 years, and this is the way it is. So yeah, very fortunate to get wisdom.
So it's kind of interesting, like the way that you're approaching it is a lot like, when Ethereum launched, they weren't sure what use cases would take off. They had a bunch of visions and ideas of, it'd be cool to do A, B, or C. And I think, from one angle, it's like when you don't have like an accurate picture of what could work, it becomes more of like an art than a science. Mm-hmm. And so sometimes you just have to put a bunch of ideas out there and see what works at the end of the day, what, developers pick up and run with. And so what is your sort of like workshopping model for coming up with what could be interesting to the market? How does that work? Like that sounds like, a lot of fun actually to get involved in and to do.
Yeah, it is a lot of fun. So far, we've done many cycles of idea to proposal to contract, and it's on network. Not prod, not all the way to prod because we're not in mainnet, but it's all of the steps, and we've now narrowed it down to some 2-week, 5-stage process where we've derived a lot of inspiration from the way creative studios do brainstorming, where everyone has to come in with these half-baked ideas. You talk about these half-baked ideas and then draw connections between the ideas. And usually the best things happen in the connections with, I like this thing from yours and this thing from yours. If we put it together, then we actually have this piece, this idea that is backed up by some core crypto principle on blockchains. Genuinely do this better than the traditional financial system. And then from there, we let the idea sit for a week. And then if it's still good in a week, then we talk to people about it. If it's good after we talk to people about it, then we get the contract together, see if it's feasible. And then from there, we'd really just love to ship it to mainnet, but we don't have mainnet yet. So we're just chomping at the bit right now.
The other interesting thing that's been happening, I think, in the space is a lot of people have solved like one piece of probably, what you guys are doing. And so when people are like building an application, they need some element of it private for a particular application level sort of necessity. Yep. You have teams that are more full stack. Mm-hmm. You have teams that can solve one of the many things that you guys are doing. Mm-hmm. But at the end of the day, it doesn't really proliferate out like beyond that. It doesn't get integrated into other applications because they're just trying to solve one problem for one, type of user, for one product. And so it's kind of interesting that you guys sort of have this like R&D model. It's a blockchain, so everything will be open source. And it actually, I feel like it can push the industry forward, whereas usually people solve a little problem, it's private in their own repo. It doesn't quite get out there, which is kind of interesting.
Yeah, thanks. That was literally us before starting the chain, where we did a lot of one-offs and custom solutions. Like we wrote an ungodly amount of Halo 2 and Circom. And then at some point we just said, let's figure out how to solve this more generally. And that's really one of the big motivators.
Talk to us a little bit about this. I'm just, seismic pilling myself as I talk. That's what's going on here.
Yeah, thanks so much.
Talk to us a little bit about the concept of the encrypted global state in your architecture.
Mm-hmm. So encrypted global state is one of the major properties that we were missing early days. We got started building a few games and DeFi protocols, and even we built a dating app too. And for all of these, it needed state that was encrypted from multiple parties that needed to talk to each other. Very simply, in a dating app, if I swipe right on you, you should know that I swipe right on you. And then if you swipe right, we should match. So both of our swipes are encrypted. They're on-chain. People don't know what our love interests are, but they go between us, and it's not fragmented. And whenever we talk in Seismic about what's the difference between encrypting a wallet versus encrypting a protocol, if you're encrypting stuff in information in a wallet, that is information that just lives on your client device. If you're encrypting stuff in the protocol, that is information that can flow between client devices and now do all of these things. Like you just gave the dating example because it's easy to do, easy to think about. But if you're going more into DeFi, then if you want to match an order, if I put an order out and then you fill the order, if you want to go into crypto-specific DeFi, if I go into an AMM and then this AMM needs to maintain some reserves that you later trade out of, all of this is encrypted global state.
Yeah, I feel like that's exactly the problem with bringing everything on chain. You guys are kind of nailing it. You just can't have everything public out there. And it also creates like a big honeypot. So one question is, how do you foresee just staying ahead of the curve and making sure, the crypto systems you have built in here are actually ahead of the curve, cutting edge, et cetera? Mm-hmm. How are you thinking about that?
For being cutting edge, I will say that we've generally deprioritized this because even today, I don't view Seismic as technologically cutting edge. I think we're using old tech and a lot of good engineering to present a solution in a way that people haven't seen before. So already today, we're not cutting edge. So that solves that. As far as staying competitive while not being cutting edge, we're thinking about it like this. Our incumbents are Solana and Ethereum, if we're really thinking long term, and then Base. This is who we're signing up to go up against at some point down the line. And one of the facts that makes me comfortable in the defensibility of our position is that to enable protocol encryption, you need changes that are so foundational to a chain that you would realistically need a hard fork. Like Solana has confidential transfers. Base has Ironfish on top of them. Ethereum has all of these different protocols with encryption on top of them. But all of them focus on encrypting wallets, not encrypting protocols. To encrypt protocols, you need to change your node implementation. And to change a node implementation, you need to accept these trade-offs that you're going to have to make some trade-offs. Like Seismic is an imperfect system. We've sacrificed a lot in blockchain design just to make this happen. And they can't make the same sacrifice because they're currently making these as guarantees. Like Solana is making guarantees about 400 millisecond block times, where it's going to be sitting at probably between 1 to 3 seconds when we go to mainnet. And if they wanted to switch over to this encryption, they'd have to give up this current guarantee, which is their current value prop. So with current incumbents, we're less worried about defensibility. With other projects around encryption, not a lot of them have focused solely on encrypting protocols and taken the very hard everyday consumer approach that we have. Once they do, we're going to do our best to make sure that we're in a spot where the developers that we can put together, given the network that we've built, is enough to go head to head against them. All this to say, generally, the people that we're really, really worried about probably can't do this anytime soon. The people that we're very still worried about because they're formidable aren't interested in it, and we're prepped to go head to head. I think this is why we're 10x more concerned about just being wrong than being beaten to being right. Like as far as how I view competition.
Talk to us a little bit about encrypted data flow and how that works in Seismic.
Mm-hmm, absolutely. One of the points that I drive heavily with Seismic is generally encryption is horrendous UX. The way that you know that something is secure is a joke running around in the cares about cryptography community, where you know a product is good and secure if the UX is bad. Like Signal has bad UX compared to Telegram because of the guarantees that it gives.
Don't get me started.
Yeah. Exactly. So one of the pieces that we believe in pretty strongly at Seismic is your entire chain shouldn't be default encrypted. That's just bad UX. Like you look at a block explorer and all you see are transaction hashes and you can't click into them. Like I look at a transaction and I don't know what happens until it lands. Like there are some bits that are just fundamental trade-offs. So when we talk about encrypted data flow, that is purely because Seismic is still default public, where if you port over Uniswap and you did it, it's just vanilla Uniswap. And then we introduce these types that you can use to access these properties of encryption on top. And so data flow is between this transparent state and the encrypted state. Variables go from one segment to another when they go between, say, UN256 to, we call them SUN256, so shielded SUN256. So that's what data flow is.
How much inspiration did you guys draw from Zcash?
We derive very little technical inspiration, a lot of directional inspiration. Like Zcash was the paper that got me into cryptography and blockchain. So ideologically and like what they stand for, the work that they've done with Halo 2 and everything in that entire pipeline, Seismic probably wouldn't be here. So
amazing. Yeah. Amazing. And so talk to us a little bit about, if you can port over Uniswap, put it on to Seismic, does this have an EVM? And are you guys just adding sort of different opcodes to enable sort of like the shielded side of it? How does that stuff work?
So the way Seismic does what it does is we took all of the major memory segments in the EVM and we duplicated it. All the memory segments today are just transparent. All we did was copy and paste and say, now there's a transparent segment and there's an encrypted segment. And this is everything from call data to stack memory to long-term storage, all of the memory segments. The parts that we say we want to keep confidential, we throw that into a TE enclave, all of this. And so with our modifications, we've done modifications to pretty much every layer of the stack. It's everything from the execution client to the compiler to the testing framework to the wallet interface, mainly because this is a very different paradigm than the EVM works in. Like usually the EVM just has one place. And then now that you duplicate something that's fairly core, how the EVM works, now you need to solve things like how does the developer communicate switching between one or the other? How does the developer even load variables into one? How does a user send variables into one part of memory versus another part of memory? All of these required some sizable changes. And so our stack is a pretty deep restructuring. Although even at the end, we're on our team jokes still that our stack is still 99% what's modern and open source. There's just so much work that's been put into Solidity, Reth, Revum, Alloy, VM, all of this, that we've absolutely grinded for 9 months and we're still batting 1% of code diffs to the regular stack. So it feels like a lot and feels like a little in different ways.
Before you said that, I was going to say you can probably write the EVM from scratch right now if you wanted to.
Me, definitely not. Engineers on my team, definitely.
Yeah. So that's interesting. So if there's this sort of dual approach, in like 10 years, for example, is there a world where the traditional decrypted opcodes will just be sunset in favor of a encrypted by default sort of model?
Yeah. I mean, if that is a read on demand post mainnet, then there's absolutely a world like that. Right now, our initial hunch is that both will stay forever because of the fundamental a blockchain that's default public is just bad UX. That fundamental fact. But if people are saying, I'd rather just have everything default not public, and then we can figure out the rest, then we'd absolutely sunset the regular set of opcodes.
Interesting. This is so interesting.
Yeah. Yeah.
And